Hello. Thanks, Yasmina. All right, yeah, so today we're going to be talking about building an HTML5 video player. We're going to look at the history of web video, the current user support around HTML5 video, formats involved. We'll dive into the code a little bit. I'll walk you through some of the bugs that you might run into as you start working with HTML5 video. We'll take a look at where everything is going, and then I'll give you some resources that you can use to continue learning with, and I'll also try and answer some of your questions. Okay, so my name is Steve Heffernan, and as Yasmina said, I'm a web designer, developer, focusing on lately on web video. I'm co-founder of a company called Zencoder, and we are a cloud encoding API, which essentially means if you're looking to automate the process of converting videos, so say those uploaded by your users, you might use Zencoder to automate that process. And then we were recently acquired by a company called Greco, which is the largest online video platform. So now we're kind of one piece of a full technology stack around video. And Greco powers video behind sites like Wall Street Journal, New York Times, Showtime, sites like that. And then finally, my side project has been Video.js, which is an open source HTML5 video player, and I'll talk about that a little bit more later. But let's dive into it by talking a little bit more about me. So this is me at 6 years old, actually, and this is probably the best picture of me at 6 years old. A little later in the year, I fell off a hammock and killed my front two teeth. And to help that, they put big metal caps over my front two teeth. And then I also had a lazy eye, and to correct the lazy eye, they put a big patch over my good eye, and it was more like a big Band-Aid. And then I had those big glasses on top of that. And then I also had a speech impediment. I couldn't say R's, and to correct that, they put little plastic tubes in my ears to help me hear better. And so there was metal caps, patch, glasses, and little plastic tubes in my ears. So anyway, HTML5 video is kind of like me at 6 years old. It has the potential to someday be a fully functioning HTML element, but right now it's got some issues. And in order to work with it, we need to know what those issues are in order to work with them and get past them. But that is where we're going. The way I see it is the HTML5, say in the next few years, will take over as the dominant web video playback method. So where we started is, so back in 2000, we had video was just getting started on the web, and we had multiple plugins like Real Player, QuickTime, and Windows Media, and we had to support all those plugins in order to get video to play on the site, or we had to force users to download new plugins. And then around 2004, Flash came on the scene, and by 2008, majority of our users supported Flash, and it allowed us to deploy video once in one plugin, and the majority of our users could experience that video, which was awesome. And what's happening now is the browser developers have recognized that video is a significantly important piece of the web now. And so they've agreed on kind of the right way to implement video directly into the browser. And that's what HTML5 video is. We no longer have a need for an external plugin to get video to play on the web. And so the next generation of web developers are learning HTML, CSS, JavaScript. They're not learning Flash and ActionScript. And one other piece that will add to HTML5 taking over is once we have the consistent support among users that we have with Flash today, and we're not as far off from that as you might expect. So if we look at this chart, over the last few years, we've actually seen about 20% user support growth per year. And so, we're around 80% support today, and so you might expect over the next year we could potentially catch up to around where Flash is. However, if you see towards the end of the graph, it's starting to level off a bit, and I think that's because we're starting to hit the wall of the last line of defense where IT departments are hanging on to old installations of Windows and IE 6, 7, and 8, and it might be a little harder to get through some of those browsers and get users to upgrade. So it won't be super fast, but I think we'll hit much higher support and maybe equal Flash over the next in the next 2 years. But so today, that's still, say, 80%. That's 1 out of every 5 customers or users of yours that won't be able to view the video if you only use HTML5 video. So why would you want to start using it today? Well, first of all, it's the future. So any effort that you put into it now won't go wasted. And then secondly, it runs natively in the browser. So what we have now is essentially 2 applications involved in order to get video to play. So you have the browser application, and then you have the plugin application running on top of that. So 2 applications. And with HTML5 video, it's all built in the browser. So 1 application, it theoretically should use less of the computer's resources to get video to play and should provide a more responsive experience. So the video start faster, just be a more smoother experience is the goal. And then also it allows for more interactions with the video itself. So I don't know if you've ever tried using JavaScript to move Flash around on the page or hide and show a Flash element, but Flash doesn't like to be touched like that. It kind of freaks out and reloads itself, and so it's very hard to interact with Flash and other elements on the page. But with HTML5 video, it's a native element, and so we can do a lot more interactions, a lot more, moving, resizing of the video, and that opens the door for a lot of new possibilities around video interaction. And then thirdly, we have this promise of cleaner code. Today we have the image tag, and the promise is to have a video tag similar to the image tag where we can just say video and then the source equals video.mp4, and the video will just play on the web. We don't have to get ourselves involved with a Flash player or object embed codes and get all that nasty code in our nice clean HTML. Now today it actually looks a little bit more like this as the embed code to get HTML5 to actually work and fall back to Flash. So it's no prettier than Flash embed codes today, but the promise is a nice, pretty HTML tag, which will be nice when we get there. And then finally, the fourth and probably most obvious reason you'd want to start using HTML5 video today is these guys, the iOS devices, because Flash is not supported on the iPhone, the iPad, and the iPod. And in fact, if you look at this next chart, it kind of shows the conversion rate of H.264 video. So H.264 video is what the iOS devices require. And you can see over the last 2 years this kind of up ramp of people of websites converting from, say, older formats like the FLV format to support the H.264 format, partially because it's a better codec all around, but I think the iOS devices have really encouraged a lot of the sites out there to convert to this format that the iOS devices support. So just interesting to see how Apple has kind of helped light a fire under HTML5 video adoption. And so that leads us into the idea of the format war, as some people call it, or the idea that there are actually multiple formats that we might need to work with as we're working with HTML5 video. So the formats are MP4, H.264, the OGG format, and the WebM format. And the issue is that no one format is supported by all the different browsers. So on one side you have the open format, so the completely open source, free, they're community developed formats, and that's OGG and WebM, and those formats are supported by Firefox, Chrome, and Opera, also the open source browsers. And then on the other side you have the MP4 H.264 format, which is a royalty-encumbered format, which means that if you're using the format in certain cases, you may owe royalties to MPEG-LA, which is the governing body of the MP4 format. And those situations are more in the case of if you're like a Netflix and users are logging into your website and viewing the video behind a login. That's the primary case where you might owe MPEG-LA some money. If you're providing the video publicly on the internet and not charging for it, it's just free and out there for people to view. I don't believe MPEG-LA cares about that situation, but I'm not a lawyer, so make sure you understand your responsibilities around that format as you're using it. And so the browsers that support that format are Safari, Internet Explorer 9 and 10, and then also Chrome. And so the question might be, will we ever see kind of peace around these different formats, peace between the browsers, and will I'm kind of behind on slides, forgive me there. All right, will we ever see peace between the different formats? And the answer is kind of probably no at this point. On one side you have Apple, who has the iOS devices, and they have actual hardware in the iOS devices that is specifically made to encode and decode the H.264 codec. And so in order to support an open format like WebM, they would have to build the same hardware to support WebM into the iOS devices. So even if they wanted to, it would be not a small undertaking to get it to the iPhone users. And not to mention that they are actually a member of MPEG-LA. Apple owns patents, which is part of the patent pool of MPEG-LA. So from that standpoint, they also don't have a lot of motivation to implement WebM. And then the other side, you have the open source browsers like Firefox and Opera, who, if they implemented the MP4 codec, they would actually owe money to MPEG-LA in the way that they're using that format. And so that would cost them millions of dollars. So they're not interested in that. And then on the other side of that, it's just this principle that the web is open and free. So HTML, JavaScript, all the web is an open and free standard. And they think that if video is going to be this big of a part of the web, that it should also be based on open and free technologies, which totally makes sense. But because of these two conflicting viewpoints, I don't think we'll see anything in the near future where we have one format. But if I was to bet on one, I would probably say the H.264 because we have H.265 coming out, and there's some rumors that maybe at some point, if MPEG-LA wanted to, they could just completely open source H.264 once H.265 is there. So that's something. If I was going to bet on one, that's where I would bet. Even though I am behind WebM, and I hope that pulls forward. Okay, so as we talk about all these different words around formats and codecs, I just want to explain a little bit of how these are made up. And so when you're talking about any format, you essentially have three pieces. You have the container format, and then inside the container you have two data streams. So you have data of video, which is compressed using a video codec, and then you have the audio data, which is compressed using an audio codec. And so as we look at those formats, with MP4 you have the MP4 container format, and inside the MP4 you have video compressed using the H.264 codec, and then audio compressed using the AAC codec. Let's see. Oh, there it is, sorry. So that's the MP4 format. And then with OGG, we have the OGG container format. And inside of the OGG container, we have the video data compressed using the Theora codec and the audio data compressed using the Vorbis codec. And then finally, we have the WebM format, which is the WebM is the container, the video data is compressed using the VP8 codec, and the audio data is compressed also using the Vorbis codec. And so hopefully this just gives you a better idea of, as these different names and terms are thrown out, that helps you understand how they're all connected. Okay, so if we look at the support for these different formats across users, we can see that it's actually pretty even. They're at between 50 and 60% of all users across the formats. And actually, the MP4 format just recently took the lead. But really they're pretty even. It used to be that the OGG format had a commanding lead over the others because OGG was the very first format used in HTML5 video. So when Opera and Firefox first came out with their implementations, they only supported OGG. And so Firefox 3.5, 3.6, which were really major browsers for a long time, only supported OGG, and so that was kind of the most supported format. But now they've all really kind of evened out, and MP4 has actually come from behind to take the lead, thanks to IE 9 and 10, which support MP4, and also the adoption of Chrome. So the Chrome browser has taken a lot of the browser share market, and Chrome supports all three formats, and so that's why they're kind of all going up together now. So if you were going to choose which format to create yourself, you want to decide what format you need to support your users. So the way I would put it is if you're doing something particularly interesting with HTML5 video and you need those interactive elements, you're interacting with the video, you're building the next Google Arcade Fire demo, and you want as many of your users as possible to see the HTML5 video. If that's the case, I would convert your video to all three formats, so MP4, WebM, and OGG. And this is because there's still a small percentage of users that can only view the OGG format through HTML5. And that's through the Firefox 3.5 and 6 browsers. If you're looking to kind of reduce your conversion costs and time that it takes to get the formats you need, I'd first start by dropping off the OGG format. So the MP4 and WebM formats are comparable in quality, and they're both a little bit better than the OGG format as far as giving you a better compression for quality ratio. So yeah, if you're going to do two formats, that's just those two. And then finally, if all you care about is the ability for your users to view the video, you don't care whether it's through HTML5 or Flash, you just want your viewers to be able to see it, you can go down to one format, the MP4 format, because not only do some of the HTML5 browsers, like Safari, Chrome, and IE, support it through HTML5, and as well as the iOS devices, also Flash supports it. So you can use the exact same format that you use for HTML5 in a Flash player fallback. So from that standpoint, you can go down to one format and save yourself some money on encoding conversion costs. I do try and encourage people to convert videos to the WebM format just because I like supporting that project and the idea behind it, but more and more I see people just sticking to this one format. Okay, so to actually create these formats, there's really hundreds of tools you can use, hundreds of paid software you can go out there and buy. I'll just mention a few free projects out there that you can use that can just get you started. First one being Handbrake here, which is a project that will let you convert video to the MP4 format. It's a free project and it's a pretty good tool. And then for the OGG and web formats, you can use firefog.org. That will give you options to convert to both of those open formats. And then if you're looking to automate the process, so as users upload video, you want those to be automatically converted into formats and then published on the website, you can use a free and open source tool like FFmpeg, which is a command line tool, or you can also use the service that I co-founded, Zencoder, which is an API and helps you kind of automate the conversion process. Okay, I want to quickly talk about content protection. This can tend to be a sticking point around HTML5 video. So if we look today with Flash and Silverlight even, we have a couple options that we can do to better protect the video from users downloading the video and redistributing it across the internet without our permission. And those are, for starters, you can stream the video through RTMP streaming, which isn't a complete protection thing, but it's harder to steal the video that's being streamed than it is to grab a video that's just in a file format. So that's one step you could take. And then at the other end of the spectrum, you can go full digital rights management, DRM, with flash access or smooth streaming, which involve a key exchange with a secure server and help verify if the user that's watching the video can actually view it. And so those are today as protected as you can get around your content. With HTML5 video, we don't yet have very good options like that, and it partly comes from the idea that HTML5 is an open technology. A lot of the browsers are open around it, and so security is actually a difficult thing to build into a scenario like that. What we can start with is the idea of source obscurity. So instead of embedding the location of your video directly in the HTML, so anybody who can view the source can see the video, instead of doing that, you can hide the source in a JavaScript file off the page, or load it in through an AJAX call, something along those lines, so it's just not immediately visible. Again, not a great solution, but it's one step, makes it one step harder. And then secondarily, you can do things like time and geography limited URLs, so that that only say you have trusted users that log into your website. You can essentially ensure that only those users are watching the video, as opposed to other people in a network or later in time. That can help on those. But still, we're very limited as far as options for protecting our content in HTML5 video. And then I just want to mention quickly that native apps on the iOS device and Android are not the same as HTML5 video. Some people assume that if you're watching any video on the iPad, like do the Hulu and Netflix apps, that's actually HTML5 video, but it's not. Those applications are using a lower level technology in the iOS devices, and that's why you see companies like Hulu and Netflix doing native apps instead of allowing video to be played on the web through the iOS devices. Okay, so I should mention though that there is a specification, a proposal being developed by Google, Netflix, Microsoft, and other collaborators to talk about how that would actually work, how content protection would work in HTML5. And so there's talk around that and a potential future for some kind of key exchange happening in the browser. And probably still a long time out, but you can point to this as there is a potential future for that in HTML5. Okay, so moving on, now we can kind of dive into the code. We have a good background on some of the technologies behind it, but let's get into actual code and look at what it takes to get HTML5 video playing on your web page. And it starts with what we looked at before, this simple video tag. So we have a tag like the image tag, but it's video with a source that points to a video that's already been uploaded to the web. And then an attribute, the controls attribute, essentially tells the browser whether or not to show controls, like the play and pause button over the video. And then an ending video tag. So unlike the image tag, which doesn't need an ending tag, the video tag does need an ending tag, and that will make sense in a second. Now with this tag alone pointing to one format, this will reach say the 60% of that one format. So all the different formats support around 60% of users, and so with one format you can essentially reach 60% of your users. Now if we want to get to that 80%, so the 80% of our users that support HTML5 video, what we do is drop the source attribute from the video tag, and instead provide source tags inside of the video tag. And the source tags allow us to point to multiple versions of the same video. And so in this case, I have all three, an MP4, a WebM, and an OGG file. And so they're all three versions of the same video, and it allows browsers to look through that list and find one that they can support. And so you'll see the type attribute to the right of the source that says video/MP4 or video/WebM, and that's actually a very useful attribute for the browsers, because they can, instead of downloading a piece of the video to decide if they can support it, they can just look at that type attribute. And I should mention that you should always keep the MP4 version first, and that's that's an issue from actually the original iPad. So iPad running iOS 3 actually would not look past the first item in a source list. It would check the first item, see if it could support it, and if it couldn't, it would just stop. Whereas browsers are supposed to continue looking through the entire list for one that it can't support. And so for that reason, we always keep the iPad, the iOS compatible source first. Okay, so with this setup, we have our 80% of users that support HTML5 video. They can all view the video now. But what if we want to get up to the same 99% that we have with Flash today? So in order to do that, what we do is actually include a Flash fallback player. So what happens in this case is, well, here I've embedded a Flash fallback. So this is a demo object of what you would normally see as an embedded Flash player. And what we've done here is include it inside the video tag after the source tag. And what happens here is all the browsers that don't support HTML5 video, so IE 6 through 8, they're going to look at this code and they'll see the video tag and they'll see the source tags and they'll have no idea what they are. So they're just going to skip right over those tags and go right to the tag that they do understand, which is the object tag or the embed tag. And they're going to load up whatever is in that tag instead of the video element. And so that's just a nice natural way that's kind of built in for falling back to a Flash player. And that makes it pretty easy. Okay, so and then with this setup, we're now reaching majority of our users with HTML5, and then we're falling back to a Flash player to reach the remaining amount of our users up to, say, 99%, or as many support Flash and HTML5. And then finally, if you really want to take it to the next step and support the 0.001% of your users that don't support HTML5 or Flash, but might be able to support the video outside of the browser, what you can do is essentially include a fallback image and some download links directly to the video files. So what I have here is an image inside of the Flash embed that will show if the browser doesn't support Flash. And in there you could have just a title that says can't play video or something else. And then below it, links, I just have a simple paragraph that has direct links to the video file. So what we're talking about here is users that might have an older Palm device or just have Flash and JavaScript turned off in their browser. So they might be able to, they can't watch the video in the browser itself, but they might be able to download the video and watch it outside of the browser. And so this setup would support those users as well. Now, obviously, if you want to protect your content, this is probably not the route you want to go. But if you just have an open video that you want everybody to see and you want to make sure the widest range of users can see it, you can take it to this level. Okay, so with that simple code, you can get I guess sort of simple code. You can get video playing on your website through HTML5. And so from there, we can kind of look into, well, once we have HTML5 video playing, what are our options around customizing the video? And so we have a number of other attributes we can include in the video tag, starting with the controls attribute that we talked about before. And that turns the controls, the native controls, on or off. The only reason you might want the controls off are if you're building your own controls, so you're building your own controls in HTML and CSS and JavaScript, and you don't need the native controls. Or if you're using video as a design element, like you have a video of looping clouds in the background or something like that, and you don't need controls over that video. For that reason, you might not include the control attribute, but otherwise you would probably most likely include controls. And then next you have the poster attribute, which you provide the poster attribute with a link to a URL to an image, and it will show that image in place of the video until the video plays. And so that would be used for, say, a title title image instead of just allowing the screen to be black until the user clicks play. Next we have the preload attribute, which tells the browser whether or not to start loading the video, so start downloading the video as soon as the page is loaded. And so you'd say auto, you give it the setting of auto if you do want it to download immediately, or none if you don't want it to download immediately. And this comes down to a balance between responsiveness and bandwidth. So if you want the video, if you really want the video to play as soon as the user hits the play button, you probably want to start preloading the video as soon as the page loads. But if you have multiple videos on the page, or you're just not positive that the user will definitely watch the video on this page, you probably don't want to preload the video, because then you're using bandwidth for both you and your user that may be wasted. And so for this reason, actually, Apple has blocked the preload capability on all iOS devices. And that's just in the understanding that, their users, the users of the iOS devices, might have expensive data plans, and they want to make sure that their users aren't forced to download any video that they don't specifically want to watch. And that makes sense. And so they've disabled the preload option. And that goes the same for the next attribute, autoplay. So on the iOS devices, you also can't automatically start a video. And that's what the autoplay is used for, is to automatically start a video as soon as the page is loaded. And so you can do that in every browser except for the mobile devices. The next attribute is loop, and rare cases where you might use that, but again, the looping clouds example, you could use loop to make sure the video goes right back to the beginning and starts playing again once it finishes. The width and height attributes you can use to set the viewing rectangle of the video, just like any other HTML element. And around this, I would recommend that you set the element size, the width and height, to the same size as the video if possible, because that just avoids forcing the browser to do some scaling of the video that might use more processing power than not having it scale. And then finally, the last one I have here is tracks. And so the track tag is an additional tag you can have inside of the video tag, just like the source tag. And what that allows us to do is provide timed text. So things like captions, subtitles, chapter titles, descriptions, that all are related to certain times in the video. The track element allows us to provide that information to the video, so it can show the captions or show the subtitles as those times come up. And so that's the track element has limited support today in browsers. Actually, Google and Opera probably had the most support for the track and the WebVTT text format, which is the format that you need to provide the time text in. So those two browsers have the most support. The other browsers are following. But yeah, very soon we should have support for captions across HTML5, which is important considering there has been new regulation in the U.S. that says that any TV show that has played on the TV, or any movie that's been played in the theaters, once it is shown on the web, if it has captions on the TV, it also has to have captions on the web. And so that's a new law that's in effect, and so captions are a very important part of HTML5 video now, as well as being able to support your deaf and hard of hearing users. Okay, moving on. Those are the attributes of HTML5 video. I did build just a quick form for helping you put that tag together with the different attributes, and you can go to this page, videojs.com/tag-builder, and you can just plug in your options, and it will help generate that HTML code for you if you're just looking for a simple solution to get that done. Okay, so we've talked about the HTML now, and I want to go into talking about the JavaScript. So beyond just getting the video to play, So everything we talked about before has gotten us to the point where we can now get HTML5 video to play on our website. But with JavaScript, we can actually do a lot more interactions with the video. There's a few things we can work with, the attributes of the video, functions on the video that we can use to control the video, and then events that the video triggers that we can listen for and react to. And so I'm going to dive into that now. I'm going to attempt a screen share here, so give me a second to try and set that up, and we'll build out some of these features. Okay. Hopefully you can start to see some things. I'm just going to double check in my own.
Yep, it's starting to come up for us.
Okay, great. All right, so what we're looking at here is just a very simple demo page that I've set up. The controls on the video are the native controls. So I didn't build these. What I have built here and what we're going to recreate is just this simple play pause button that when we click it, it should play the video. And then when we click again, it should pause the video. And then as it's playing, we should see this blue bar continue to grow as we go along in the time of the video. So pretty simple attributes, but some cool interaction there just to get us kind of started working with the video element JavaScript API. All right, so I'm going to go back. I have a non-working version of that and a very basic HTML page. So I think you can all see that now. What I have here is just basic HTML structure. In the body of the page, I've included a simple video element. So here we're just working with HTML5 video, and I have one source for the purpose of this demo, and just have an MP4 source, and we're using Chrome, so that's okay. And I've set the width and height of the video, and we're ready to go with HTML5 video playing in the browser. Below it, I have just a div, and inside the div, I have a button element that is going to become our play button. And I've just labeled that with the ID of play button. And I should say I've labeled the video element with the ID of vid1, and we're going to use that later. And then after the play button, I have another div that is going to act as the holder for our progress bar. And then inside of that, we have another div that is going to be our actual progress bar. So we have an outer div to hold the progress bar and kind of control how wide it gets, and then an inner div that will represent the actual bar. And those are labeled current time holder and current time bar. And then above, in the CSS section, I have a couple of styles just to set the width of the bar to the same width as the video, and then set the height of the progress bar and the color to a blue. Okay, and then also below all the HTML, I have a couple of script tags. The first one is just including the Google-hosted version of the jQuery library. So for the purpose of this demo, I'm just going to use jQuery to kind of make it simple to explain. It kind of glosses over some of the cross-browser issues, so we can get straight to the point. And then I have a second script tag with some code that I've started in it. And I've set up a few variables. The first one is just a pointer to our video element. So vid1 is going to equal our video element with the ID vid1. Our play button is going to be our button element with the ID play button. And then current time bar is going to represent the inner bars, the actual progress bar itself. All right, so we have those variables set up. And we're going to start by just creating that making that play button work. If I go back to Chrome, we're going to make it so that when we actually click on the play button. Right now it's doing nothing, and we want to make sure that when we click on it, it plays the video. So go back to the code and start setting up our jQuery. So I'm going to use jQuery to just quickly reference our video element with the vid1 variable. And then I'm going to use the jQuery click function, which sets up an event listener for a click on the play button. And what we're going to do is pass the click function a function that we want it to call. So anytime a click on the play button happens, we want it to call this function. And in the function, we can simply say vid1.play. And so on the video element, we have a number of functions that we can use to control the video, and one of them being play. So when we call in JavaScript a video element and say play on it, it will start playing the video. And so just to recap, we're listening for a click element, and anytime a click happens, it should tell the video to play now. If we go over, reload the page, and click the play button. Oh man, really? Did I break something? Vid1.play. Is the video playing? Oh no, something wrong with Chrome altogether. Let's see if I can't just quit Chrome and get that going again. Wow, this is the problem with live demos. Let's see if we can do vid1.play. All right, well, should be working. And I wouldn't be surprised if one of you sees a problem in my code out there. Vid1 is the video element. We do a click. Oh, okay. My fault here. Okay, so with jQuery, I should not be grabbing the video element because we're not clicking on the video element. We're clicking on the play button, and that was just a really dumb mistake on my part. I apologize. So now, instead, we're using jQuery to grab the play button, and we're watching for a click on the play button. And when that happens, it should tell the video to play. Okay. And we go back and click play. All right, thank you. It's now working. Great. Now I'm going to go back to the code. If we notice, if I click play again, it won't pause. And what we actually want is that when you click on the button once, it should play the video, and when you click on it again, it should pause the video if it's already playing. And so in order to do that, we're just going to put a conditional statement inside of our click function here. And so we'll say if statement, and there are attributes on the video element that we can use to know certain states of the video. And so in this case, we're going to use the paused attribute. So there's a paused attribute on the video element that we can look to figure out if the video is playing or if it's paused. There is no playing attribute, so don't try video.playing. There's nothing there. It's the paused attribute that we use to determine if the video is playing. And so we'll go ahead and say if the video is paused, and we're going to take this line that we already wrote and say we want the video to play. So if the video is paused, we want it to play. And then otherwise, else, the same line, let's say vid1.pause. And so there's another function on the video element called pause that allows us to pause the video. It's pretty straightforward. And I should mention that the default state of the video element is paused. So even if the video has never been played, vid1.pause should be true. And if we save that, go back to our browser, reload the page, We play, should see the video start playing, and then click the button again, and it should pause the video. Okay, great. So our play pause button is working now, and we've now worked with 2 out of the 3 different things we can work with around the video element. So we worked with an attribute like paused, and then a function like play and pause. The next thing we're going to do is listen for events on the video element and react to those events as they happen. So in order to do that, we're going to build out our progress bar. And in this case, we are actually going to grab the video element with jQuery. And jQuery has a function where we can bind to events or add event listeners that works cross-browser. And I believe the new terminology is on, but we're going to use the old terminology, which is bind. And we're going to bind to an event called time update. And time update is an event that is triggered regularly as the video element is playing. So if it's paused, this event isn't being triggered, but as the video is playing at a regular interval, this event will be firing. And so we're going to bind to that event and give it a function that we want it to call every time the time update event is fired. All right, so in this function, the first thing we want to do is calculate how far through the video we are, because we want the progress bar to match up with how far through the video we are. And so we'll set up a quick variable called %, which is going to hold this value for us. And we can access a few more attributes on the video element to tell us this information. The first one is the current time attribute, which will return the current time of the video in seconds. So if we're a minute through the video, it will return 60 as the value for current time. And then we're going to divide that by the total duration of the video. So if it's a 2-minute video and we're a minute through it, it's going to return 60 seconds for current time, 120 seconds for duration, and it will give us a value of 0.5. So then what we want to do is actually we're going to multiply this number by 100 to give us an integer value. Right now that division is going to give us a decimal value, and we want an integer value because we're going to append the % sign to it later, and that'll make sense in a second. And what we're going to do now is take our current time bar, the div element that has a blue background, and we are going to set the width of that. And so every time this time update event gets triggered, we're going to re-update the width of our time bar. So I'm just going to not use jQuery for this one and access the style attribute, which controls the CSS of JavaScript or of an HTML element. And we're going to give it a width of our %, so the % value that we just created, and append a % sign to it. So hopefully that explains why we needed to get it to an integer value, because we're essentially setting a CSS width of this % on the element itself. And that's going to be a % of the width of the outer div, our current time holder. All right, so assuming I didn't make any other mistakes there, should be able to save that and go over and reload the page. And as we click play, we should see the current time bar start to update and grow along with the time of the video. So as we're halfway through the video, it should be right at the halfway point of the video display there. And so good. So that all eventually works, and you can hopefully see how you can take that information, working with attributes, functions, and events, and look through the other options we have, the other options we have around working with the video element. So we can do things like control the volume. We can send it to full screen, and these are all other other functions that we can work with on the video element and build similar controls to these that are over the video element now, or any other interaction that we want to attempt. It gives us the JavaScript API gives us a lot of flexibility and power around working with the HTML5 video elements. Okay, cool. So I'm going to try and get out of this screen share and go back to the slides. And all right, you should be able to hopefully see that now. Let me get back to the slides. All right, so moving on. Now that we can embed our HTML video or HTML5 video and work within the JavaScript API, I want to dig into some of those bugs and issues that I mentioned earlier in the program that you might run into as you're working with HTML5 video. And some of these are kind of more a look back at history, and probably a lot of these are probably not necessary to deal with today, but we'll take a look at them just to understand kind of where we're coming from. The first one in the list here is just an example of how for a while there, the first few years that HTML5 was first available in browsers, the specification, the instructions that told browsers how to build HTML5 video was constantly changing. It was being updated as people made new decisions about the right way to build video in a browser. And so an example of that is originally we had this attribute called autobuffer, which kind of did the same thing as preload, but then they made some changes around it and it became preload. And so for a while there we had some browsers that supported the autobuffer attribute and some that supported preload, and we had to know how to use one or the other. I believe Firefox 3.5 still used autobuffer, and so it's probably not a big issue today. It's probably not something you need to worry about, but just an example of where things have kind of come and changed over the years. The second one here is another example of that, the cross-browser load progress tracking, in a sense, trying to figure out how much of the video has been downloaded. So not necessarily how far through the video is, but like how much of the video data we've been downloaded. There used to be multiple methods for how to do that. And thankfully the browsers have come together and landed on one solution. So it's only an issue in older browsers like Firefox 3.5, which I think is a very, very small percentage of users these days, which is awesome because we can start not worrying about these issues. And then some earlier versions of Safari had an issue where posters wouldn't show. And that's another one where I believe these versions of Safari are no longer really being used, and Safari users are pretty good about upgrading. So just kind of a look back at issues that we come from, and if you're starting on a video player today, you probably don't need to worry about these, which is nice. This last one, the HTML5 browsers not falling back on incompatible sources. The idea here is, earlier I talked about the idea that older browsers like IE 6 through 8 will naturally fall back to your Flash player. So if you embed a Flash player inside the video tag, those older browsers will fall back to it. Now in the case of other HTML5 browsers, for an example, say you are just including an MP4 source. You have a video tag with an MP4 source and a Flash fallback, but no WebM source, no OGG source. If you view that in Firefox, Firefox will look through the list of sources and not find a format that it does support, and it will just stop. It won't fall back to the Flash player. And so for that reason, we can't use necessarily that natural fallback if we're limiting the number of sources we're actually converting our videos to. So that was just an example of the Flash thing. Let me jumping ahead in slides here. I think it's catching up. Okay, so here's an example of how you might get around that issue. In this case, I have I'm creating something that I should say that with a lot of these demos coming up, you can probably do a lot of copying and pasting. I think we will try and make the slides available. I need to double check to see exactly how we'll do that, but otherwise I'll make sure to kind of tweet these slides out so you don't need to be frantically writing down this code as I'm going. We'll make sure this is available somewhere. But essentially what I'm doing here in the code is creating a quick test to determine if the browser does support HTML5 video. And what we can do there is essentially create a video element, use JavaScript to create a video element, and check for a function on that element that we would expect to be there in HTML5 browsers. And in this case, I'm using the canPlayType function. So as we create a video element in browsers that support HTML5 video, that element will now have a canPlayType function, whereas older browsers will not. And so that's a pretty easy way to check if HTML5 video is supported in a browser. And so in this code, I'm using that. I'm also using the canPlayType function to check if, in this case, if the browser supports the MP4 format with video/MP4. And so in this case, if I know the browser supports that, I can provide the video tag with that source in it. And show HTML5 video to the user. Otherwise, in this case, I'm checking the Flash version that the user supports. And I'm using SWF object or SWF object, which there's a link at the bottom of the page to that to help me determine which version of the Flash player the user has. And if they don't have a version that my fallback Flash player needs, I can then fall back to something that tells the user your browser does not support video or something else in that place. And hopefully that's clear enough that you can just kind of, if you're looking to do this, you can use JavaScript to make that decision for you. Okay, so the next thing to talk about is some of the issues that came up in iOS 3. The first one we mentioned, the need for the MP4 source to be the first in the source list, and that was because the original iPad wouldn't look past for that first source. And so that's easy fix, just make the source first. The second bullet point, which kind of lost the bullet point here in the translation from Keynote to PowerPoint, but second bullet point is actually the iPad poster attribute bug, which is an issue where if you included a poster, it could occasionally break video playback on an iPad. So if you have a high number of users that are using an iPad with iOS 3, you might run into that issue, but that's less frequent today. We're up to iOS 6 now, and with all of these, Apple is actually suggesting not supporting iOS 3 in native applications. So they're discouraging support for iOS 3, at least natively. And so for most of us, I think we can ignore iOS 3 as a platform that we need to continue to support and work through these bugs. But for some of you out there that have very large websites that might have hundreds of users that are still on iOS 3, and this is important to you, it's good to know that these issues might come up, and I have a few fixes for these. No, I don't have fixes for these. In this case, the iPad poster attribute bug, you just not include a poster if you think that's going to be an issue. And then the last one is there was a weird issue around including JavaScript in the same page as HTML5 video. It was a thing where if you included JavaScript in the head of your HTML page, any JavaScript, so just you're including a link to a JavaScript, to a jQuery library, it would sometimes break video in the iPad, whereas if you move that JavaScript to somewhere else in the page, like before the end body tag, video in the iPad would work, but it would sometimes break video on the iPhone. And this is a very frustrating bug, and it's the only way I really found to get around that is by setting the source of the video through JavaScript. So there's a .src function that we can call on the video element to load a source, and that was the main way I found to get around that. But again, for most of you, iOS 3 should not continue to be a concern for you, and so that's fortunate for most of us. Okay, the next thing to talk about is Android bugs. And unfortunately, whereas with iOS 3, those users are fewer and far between, Android has a much more scattered landscape of versions. And it has to do with how many different vendors are involved in the upgrade process. You have all the phone manufacturers and the actual phone networks, and so it's very scattered who supports which versions, and a good portion, 25% of Android users, the last time I checked, still had these older versions of 2.1 and 2.2, which had some kind of major issues around HTML5 video. So I do have a couple of quick fixes for these, and I'll just walk through them. And again, you should be able to just copy and paste a lot of this JavaScript code. The first one is in Android 2.1, you could not touch the video to start it. So you could load in an HTML5 video, and the phone actually did support HTML5 video, but there was no way for the user to actually touch the video and make it start playing. And so that was a big problem. The second one is actually also in that first bullet point, where the type attribute. So earlier I talked about the source tags and this type attribute in the source tag that was important to tell browsers what type of format it was, so they could immediately know if they could play it or not, and then skip it instead of trying to download a piece of the file first to determine if they could support it. In earlier versions of Android, this would actually break video playback, just including the type attribute. And then the third one is the canPlayType function that we used earlier to determine which formats the browser could support. Was just completely broken. It would always return that it couldn't support any video. So I have some fixes for this, and the first one, the Android just touching the video to start, is just a quick JavaScript snippet that if you plug this into your page, it'll detect if the browser's Android. We're using an user agent match here, which is not super pretty, but it's the best solution I've found so far. If you find a better one, let me know. But attempts to detect if the device is Android, and if so, in this case it's using jQuery to make any video element have a quick function on it that starts the video playing. And that's essentially what that snippet is doing. It's pretty simple and just gets around that issue. For the type attribute issue, there's a few different options you can go with. The first one is just not including a type attribute. And I mentioned that that's a good thing to have for browsers, but a quick fix would just be to not include it if it's an issue and you don't want to dig into other ways of fixing it. It just puts the responsibility with the browser to determine if it can support the format, but it does get around this issue. Secondly, is to not use source tags. So if you know for a fact you're only going to use the MP4 format, then you don't actually need the multiple source tags inside the video tag. You can just include the source attribute that we showed in the very first example of the video tag, and use that to load the video. And that actually gets around the type attribute issue. And then thirdly, you can set the source through the JavaScript API, and that's something that I mentioned as a way to get around some of the iOS 3 loading issues or video playback issues, and in this case it also gets around the type attribute issue. And so in this case you would wait for the page to load, and then you'd find the video element in JavaScript and set the source to the source that you want to play. That will get around that issue. Okay, so the last one is canPlayType fix, which this is a big, ugly snippet, so definitely just a copy and paste. But essentially what it's doing is looking for, trying to match if the device is an Android, and if so, it's going to override the native function. So it's actually going to go into the video element and replace the native canPlayType function with one that actually will return that it does support the MP4 format. And so, hopefully you can just copy and paste this, and this will help get around that issue for your Android users on those older versions. Great. So those are kind of the major bugs that you can get around with those fixes. Okay. So the next thing I want to talk about is the future of HTML5 video and where we're going. So now we have our video playing, and we can work within JavaScript API, but there's still, I mentioned there's still some limitations around HTML5 video and reasons why we might continue to use Flash today, but a lot of those are being addressed. And so this first one here I mentioned, the content protection API. The name is the encrypted media extensions, if you want to go look it up in the W3C specifications. And the idea that would do is allow for key exchange between a key server behind the browser, which if you don't know everything about security, essentially helps you verify that the person watching the video should have access to it. And so it's again, never going to be a perfect solution where you can be sure nobody can access the video. And I should say with any content protection, there's always what we call the analog hole, which is where you can do some kind of screen capture software to grab the video off the computer, or as much as putting a camera in front of the computer to videotape the video as it's playing. There's always going to be that analog hole that makes it impossible to completely protect a video that's playing on the web. There's always going to be some way for a user to get it. But all of these steps try and help make it a little bit harder to make the content owners feel more comfortable with allowing their content on the web. And so hopefully this new proposal will help move us further in that direction. Second, we have the media source extensions proposal, which directly applies to adaptive streaming. So with Flash and Silverlight today, we can detect the user's bandwidth and provide them different versions of the source depending on how fast their connection is. And the goal here with the media source extension is to give us an API to, instead of providing a URL to a file, to actually pass in video data. So the actual bits, we can continue to load them into the video element. And so that allows us to switch the video quality as the video is playing without interrupting the video, and also do some interesting things around video editing. And it really opens up a lot of doors to messing with the video as it's playing. And so I'm excited for that to be available. We talked a little bit about the track tag and the time text events, and those specifications are really coming along, including the idea of being able to trigger not just time text like captions and subtitles, but be able to trigger other events on the page or make other interactions happen on the page as the video is playing. So if you're looking to do things like that, the WebVTT format and the track elements are going to be the ways to do that. There's also the WebRTC proposal, which is concerned with video chat and direct connection. So essentially like Skype in the browser is what the WebRTC proposal will help make possible. And then there's a number of new formats and codecs that are under development that could become part of HTML5 video in the future. And that includes, so BP Next is the ongoing progress of Google's work on WebM and the VP8 codec. So they're continually making it a better format and releasing new versions, and it's just getting better and better. Then you have the H.265 codec, which is the next version after H.264, and I'm not sure exactly when that will necessarily be available, but that's kind of the next iteration of the MP4 format. And then you have the Opus audio codec, which is under development by the same group that does OGG and Theora, and that's looking to be a really high-quality audio codec, and is actually slated to be the audio codec for the previous proposal, the WebRTC proposal is setting Opus up as the audio codec that will be used in that proposal. And then transog is actually the ongoing work or the next iteration of the OGG format. So they're trying to kind of improve that format. Okay, so that's the future. Just have a few more things. Okay, so Video.js, just talk about that quickly, is my side project. It's an open source HTML5 video player. If you're looking for, if you're building your own and you just want examples of how, say, I've gotten around some of the issues out there or how I've done things, you can feel free to look at the code in this player, see how I've done things, or even just use Video.js as kind of a starting point to get into HTML5 video. Some of the additional features that it has is the full HTML skin, so the play and pause button and controls are all built in HTML and CSS, so you can kind of make controls look different just using CSS, which is nice. And then it also has the same API to HTML5 and Flash. So before in our JavaScript demo, we were showing the way we set up our JavaScript would only work in HTML5. But with Video.js, we've set it up so that if you call play, if you call the play function on a Video.js element or the Video.js object, it will play whether or not the video is being played back in HTML5 or Flash. So that's kind of a nice feature of that library. Other resources, you have Video for Everybody, which is kind of the original resource that people use to get into HTML5 video and first showed us how to do that kind of natural fallback to a Flash player. It's still a very solid resource and has a lot of information on kind of specific device issues you might run into. I think I might be able to push some of these to you. Let's try this. Let's see. You might have gotten the Video for Everybody one window there. And I'll try pushing the Video.js one to you. So who knows? Maybe you got those. I don't know for sure. And okay, so next resource would be Dive into HTML5 Video, which is an awesome resource for just all things HTML5 and has a specifically good section on video itself. So another one to dig into if you want to continue your learning around this. There's also, I did a video series on lynda.com, which is essentially a lot of what I talked about today, just kind of goes deeper into specifics of the attributes and goes further into building the more of the controls around video. And so just essentially a longer version of what today was. And that I believe is it. Yes, that's it. And so yeah, big thank you from me and O'Reilly for attending. And I think I will attempt to answer some of your questions now.
Great webcast, Steve. Very fascinating and just, oh my goodness, so much information. And our audience is chatting away and their comments are spectacular. They really enjoyed the event. Folks, we are at Q&A now, and we are running a little out of time here. So Steve is going to take a couple questions, and that's all we're going to have time for. So Steve, if you can see them, please have at it.
Okay. So let's see, just going down the list. Jin Chen asked, why do you use document to get element ID to get the elements, then use jQuery to pick up the element? We can use jQuery to get the elements directly. You're absolutely right. I mean, I should just be using jQuery throughout the thing. I tend to not use jQuery, so my default is to not use jQuery and then use it only when I need to make things look simple. And so hopefully that answers that question. The second one is, how can I override default HTML5 video controls and styles? Different browsers show different styles. So hopefully the demo that I showed of how to build those JavaScript controls gives you an idea of how to get started building your own controls. And essentially you would not include the controls attribute in the video tag if you're building your own controls. And then you can build all your own controls in HTML and CSS and JavaScript. And feel free to look at Video.js as an example of how I've built those controls in HTML and JavaScript. Third question here, why is Windows WMF not mentioned? I'm not totally familiar with WMF refers to, so I may have to come back to that one. If you mean WMV, WMV is just not a, I think if WMV is supported, it's only going to be in the Internet Explorer browsers, and so I don't include that as an option in the formats, but maybe I should look into it. Next question. New formats are always interesting, but do you think there will be one fully supported video format across all the browsers and mobiles? And if so, what? I think I touched on that, and my bet is that if there's going to be one, it's going to be the H.264 codec in the MP4 format, just with the hopes that MPEG-LA will decide to open source that at some point, because it's already the dominant format, so we're just kind of waiting and hoping at this point, I would guess. Next question is, how about the progress scroll bar? Is that standard widget in HTML5? It is in the default browser's controls, so you can scrub along the time bar to kind of change the time of the video. Video.js has an example of how we've implemented that in HTML. I didn't go into that in the JavaScript demo here today just because it takes a lot more code. I do go into that in my lynda.com tutorials if you're really interested in building that out. Or actually, I don't know if I go into that in the Lynda now that I think about it. So Video.js is probably the best place to look. What are the best resources, books, websites, forums, open source you recommend for HTML5 newbies? Okay, I think I covered that in the last resources, so hopefully that question was answered. Next question is, does the video set an event when the video is done playing? Yes, in fact it does. The video will trigger an ended event, so ENDED is the event that it will trigger when the video is done playing. And so you can use that to load up another play button or to go on to the next video. There is that option. Next question is MKV Matroska an HTML5 technology? I don't know a ton about Matroska, but I do know that the WebM format was based off the Matroska format. And so in that sense, it kind of is. But as far as other support for Matroska, I'm not sure. Emily asks a second question about WMF. Most of our webcasts are through Windows Media Player, and not only our mobile webcasts are MP4. Wow, okay, so WMF is definitely a concern here. And yeah, I don't include the Windows Media Player as a fallback as opposed to Flash. I don't include Silverlight here. I've defaulted to Flash as a fallback because it's supported by the majority of our users. But it sounds like maybe I should look into WMF as a potential option within HTML and fallbacks. So apologies for not having more information on that. And then it looks like the last question is, what is the definition of interactive video? Is it on a frame-by-frame basis, or are we talking about the ability to fast forward and rewind, etc.? Let's see, I mean, this interactive video, could be an incredibly broad term. You could look at it as the idea of, yes, you can scrub along the timeline and control exactly where the video is playing from, and just the basic controls of changing volume and going to full screen, that could be considered interactive video. I think how I might have mentioned it earlier when talking about HTML5 versus Flash is the idea that in a browser you can actually be more interactive with the video as far as hiding it and showing it and changing the size of it and overlaying other elements on top of the video, just more interactivity between the HTML page and other elements on the HTML page and the video that were previously not available through Flash, because Flash would have issues as you try to move it around and do things with it. It would force it to reload and screw a lot of things up. And so hopefully that answers the question around interactivity. That's the end of the question and answer list that I see. Yasmina, do you have any others?
Let's see. Looks like one just came in. I'll just read it real quick from, looks like Tabor. Do you have any resources to investigate server-side issues on iOS, like range download requirements and pitfalls?
For server-side issues on iOS, gotcha. So you're essentially looking to figure out essentially monitor the traffic and what's happening within an iOS device to get a better idea of what's happening with the video and why issues might be happening. And unfortunately, I don't know any specific tools that I would recommend. Within HTML5 itself, the Safari web browser and the Safari browser within an iOS device tend to be pretty similar. So from that standpoint, you can potentially try working with the Safari web browser on a Mac first to see if you encounter the same issues. But otherwise, I don't know that having specific tools directly on an iOS device to kind of help you get through that. I think there's some tools out there that let you control web browsers and view control web browsers on a mobile device from your desktop, and I'm blanking on the name of it right now. But there are tools out there that kind of help you debug things on a mobile device from your desktop, and I would be looking into something like that, I think, to be looking for video errors in the console as they come up on an iOS device. And sorry, that's probably not the best answer to your question, but hopefully that gets you somewhere.
Great. I'm not seeing any additional questions. So with that, Steve, on behalf of O'Reilly Media, thank you again so much for presenting today's webcast, for sharing all your knowledge and expertise with us.
Mm-hmm. Oh, really quick, I have a coupon code, or essentially our parent company, Brightcove, has a introductory $5 a month option for Video Cloud that if you're looking to get an HTML5 video today and just want a quick and easy solution, that you can use Video Cloud to do that. They have really great HTML5 support. So there you have it. There's a link for you.
Great. Thanks for sharing that with our audience today. Folks that attended today's webcast, thank you for attending, and we hope you benefited from it. And again, judging by all the comments in the chat box, you sure did, and it was a really great event. So again, thank you, Steve. Thank you, everyone. This will conclude today's webcast. Goodbye, everybody.
Thank you.